Good morning or good afternoon, everyone, depending on where you are joining us from. Thank you so much for joining us this morning in this webinar on continuous performance testing in the DevOps pipeline by Lee Barnes. Lee is a CTO of Utopia Solutions, a consulting company that helps many organizations in all types of QA and testing. I'll let Lee give you a brief view on that. For now, this webinar is being hosted by the International Institute for Software Testing. The International Institute for Software Testing offers training, certifications in software testing, and now is through the parent company is offering also certifications in Scrum and different Agile approaches. Not going to take much of your time to do that. Just want to tell you that this webinar is being recorded and will be made available at the IIST website next week. Simply go to testinginstitute.com, the place where you signed up for the webinar, and then you'll see a link to the recording there. You can always write your questions during the webinar through the questions tab, and I will be helping Lee at the end of the webinar to read those questions back to him, so he will be able to answer as many questions as he can. For now, I'd like to turn it over to Lee Barnes. Lee, thank you so much.
Thank you. Yep. Thank you, Magdi, and thank you to the IIST for having me today. And of course, thank you to everyone for joining the session today, where I'll be talking about continuous performance testing in the DevOps pipeline. I want to start before I dive in and talk a little bit about the origin of this talk. Over the years, I've worked with a lot of large enterprises that have set up centralized performance test teams that provided essentially performance testing as a service to various business units, projects, application teams. And that served those organizations very well for a long time. But as the waterfall era transitioned more into iterative development with Agile and certainly DevOps, they started facing a lot of issues, and we'll talk specifically about what those issues were. But the process of transitioning from the centralized performance testing center of excellence, if you will, to more of a continuous evaluation of performance is really what this talk is about, and some of the techniques and obstacles that you might encounter. So let's get started. Very briefly, as Magdi said, I'm CTO of Utopia Solutions. We focus on helping organizations with software quality and testing initiatives. Most of my experience is focused on test automation and performance testing. So let's get started. This may come as a shock to anyone on this webinar that might fancy themselves as performance test engineers, but performance testing is dead. Now, hopefully that I have your attention. Let me qualify that statement and add that traditional performance testing is dead, at least in Agile and DevOps environments. And to understand why I might make such a controversial statement like this, let's take a closer look at what traditional performance testing generally looks like, thinking back to what I just talked about in that large enterprise performance testing centers of excellence. So traditional performance testing, again, was born out of the waterfall model, where a single cycle stretched out over many months, in some cases years. And then after the functional testing was completed, we developed and executed a large-scale system-level performance test, and that in and of itself may have lasted many weeks. And I spent a good portion of my career helping organizations set up these centers of excellence, and that, again, as I mentioned, became very effective at executing this big bang style of performance testing. But along with that, we often had to enforce very strict rules that went along with that. For example, if you want us to test your app, you need to pay attention to the following. Your app must be functionally complete, because if you can't prove that it works with at least a single user environment, how in the world can I test it under a multi-user load? And for the entire time that we're doing our work, which consists of planning the performance test, developing scripts, executing and analyzing the results, don't dare change the code, or I may have to start the whole process over again. And if you want your results to mean anything, then you better supply me with a production-like environment. So, and again, in large enterprises, especially with long development cycles, this worked very well for a very long time. But let's say we do that, and maybe even now in more modern software development, iterative software development, we decide that we're going to have a hardening sprint, and part of this is that large-scale, big bang system-level performance test that we talked about. What happens if we find issues after we've completed development of the entire system, or even for that matter, maybe just a feature? Our options aren't good, right? We either delay the release, which means we're delaying delivering the value of the system and of the features to our customers, or we get hit by what I call the freight train. And so very similar to standing on the railroad tracks and turning your head to see the train right before it hits you. There's not a whole lot of time to do anything, right? And that freight train has lost revenue, it's lost brand value, it's lost customer loyalty. It's also the increased cost of remediation compared to if those issues were found and addressed much early on. But either way, our options aren't good. And if you think about it, even back in the waterfall days, if we found serious performance issues that were at the architecture level, there was a large remediation cycle that may have had to happen before we could release the application. So while on the surface that model seemed to work very well, if there were serious problems that were, again, deep rooted and required a lot of remediation, getting the first idea of performance about your application at the very end was not a very good idea, certainly in hindsight. So the problem worsens, right, if I try to perform traditional performance testing at the end of each development sprint, right? At first glance, this might seem like the logical approach. And the thought is that if I start relatively small and I build and maintain the performance test as I build my application, then I can keep up. But the reality is that there's no way you can follow those strict rules of traditional performance testing that I mentioned if you're taking an agile approach to development. If we wait until new features are functionally complete and tested, there's no time to enhance and maintain the performance tests. And we certainly aren't going to freeze our code for an entire sprint, or worse, multiple sprints, while we develop and execute that performance test. And it's very, very unlikely that, at least early in development, that we're going to have anything that resembles a production-like environment. So we end up trying to combine these short, agile development cycles with these lengthy, rigid performance tests, and we end up with a real disaster on our hands. And that's what these organizations were finding as the development teams transition to agile. The performance test centers of excellence were trying to operate in their old way, and it just didn't fit. And they became essentially irrelevant to the organization. And as they started to realize that, they started through various processes, a lot of trial and error, to implement what we're going to talk about here in a little bit. But so, and what that is really looking for continuous feedback on performance, right? Or the title of the talk, continuous performance. So if what we think we're searching for is continuous performance, what is that? And maybe it's best to start out with what it is not. As we just talked about, it's not more frequent traditional performance tests. Those just don't fit within the context of a delivery cycle. It's not moving performance testing earlier in the delivery cycle, right? It's not just that, certainly. And it's not faster or completely automated performance testing, although certainly automation would be a component of this, as we'll see. But what it is an appropriate level of evaluation of performance at each stage of the delivery cycle. It's more frequent, more visible feedback on performance. And an important aspect of that, as we'll see, is trending that feedback across builds, so you can create essentially a continuum of performance data as you develop your application. So, okay, if traditional performance testing doesn't work in Agile and DevOps cycles, but I think we can certainly agree that there's a lot of organizations that are building software that way, right, via a DevOps approach. Let's take a look at how they're doing with respect to performance testing. And according to the 2019 State of DevOps report, not very well. Even if we look at elite DevOps performers, we see that only 28% have automated performance tests. And if you read between the lines a little bit there in the data, given that performance tests are typically automated, we could infer that only 28% of elite DevOps performers are performance testing at all. And granted, the report isn't very specific if they're referring to just automation, so execution of the test, or also automation and integration into their build process. But either way, there's a lot of room for improvement there. So if even the top DevOps performers are lagging in terms of performance testing and analysis, there must be something standing in their way. And in my experience, there's several things. So let's take a look at some of the more common roadblocks that are encountered with respect to building performance testing and analysis into DevOps pipelines. First is a lack of performance-related requirements in user stories. If we're not thinking about performance from the beginning, it's difficult and probably unfair to expect the team to think about it as features begin to move through the development process. Similarly, development teams often lack the knowledge and experience for performance analysis and testing. And this is especially true in organizations where this function was handled by a separate team. Going hand in hand with that is the development teams or delivery teams not having accountability for performance testing and analysis. Again, especially where that traditional performance testing was handled by someone else, a separate or dedicated team. And finally, the concept of performance analysis was limited perhaps to running these large-scale system performance tests, and the organization as a whole didn't possess the skills or the tools required to analyze performance at a much lower level or much earlier in the pipeline. So let's talk about each of these briefly. And again, one of the huge holes in most organizations is really the failure to think about performance from the beginning. This hole was likely again created from legacy software development processes where understanding the performance of the system was someone else's responsibility. And I think another concern is making organizations lazy when it comes to performance, right? As it always, again, was someone else's problem. But I think a great way to begin to expose this to the organization and consider performance requirements and factors, is to consider performance requirements and factors when stories are being created. So as you're creating your stories, just thinking high level about performance factors that are important to that story. For example, let's think about the story that I'm displaying here that describes the ability of a dealer of farm equipment to create quotes in the field. Right? As I think about that, maybe I know or someone in the organization knows that we're going to have a peak of around 1,200 concurrent users that are creating quotes. And given that we're literally going to be out in the field, we need to consider varying network conditions. And we know from experience that our users don't want to deal with anything worse than 2-second response from screen to screen. And at this stage, we're just getting these factors out in the open. I don't recommend spending a lot of time on this, but it gets them out in the open early, and we're not leaving it for a performance test engineer to worry about this right before release. So thinking about performance factors is a good first step, but how can we incorporate performance requirements more formally in our work? And I've seen a handful of approaches, and I think what's right, at least from my experience, depends on how the organization prefers to work. So let's look at some examples of how organizations are incorporating performance requirements more formally. One of the more popular approaches is to include performance requirements as constraints that certain or maybe even all stories need to meet. To think about performance requirements, things like response time, support for a number of concurrent users, or some volume of throughput, they will often apply to many user stories. So as we create those stories, we can link their acceptance criteria, as appropriate, of course, to these existing constraints. For performance requirements that might be specific to a single story, it might make sense to include them directly in the acceptance criteria of the story. But we need to be mindful that user level performance criteria, things like response time or support for a number of concurrent users or throughput volume, they likely can only be tested or proven in a production-like environment. So in the above example there that I'm showing on the screen, I'm not going to get meaningful results for high concurrency, high throughput tests in an environment that isn't sized appropriately. So you need to understand that if part of your definition of done is satisfying all performance criteria, putting this all acceptance criteria, putting this level of detail as an acceptance criteria in an early story, if you don't have an environment that you can prove that, puts you in a little bit of a conundrum. So that way, if you can pull them out as constraints and then link them as appropriate when appropriate, it becomes a little bit more. You can be more true to your definition of done. Again, before I move on, I want to reiterate that how you approach incorporating these requirements should fit with the way your organization prefers to work. The key is to begin to develop that awareness of performance factors as early as possible. I think the method by which you do that is less important. Start with what makes sense for your organization and expand what works and pivot away from what doesn't. As I mentioned, these organizations that went through this themselves, it was a lengthy trial and error process. What I'm hoping to do here is give you some hints and tips and tricks to help you navigate that process. But there's still going to be some uniqueness to the way your organization prefers to work, and you need to take that into account. So another common thing that's missing for us to be able to incorporate performance testing and analysis in our pipelines is accountability. And it's not surprising that we see a lack of accountability. Right? There's still a lot of inertia around that traditional performance testing where, again, it was someone else's responsibility. So I think accountability really is a combination of awareness and visibility. And we just talked about awareness. I believe awareness is an important prerequisite. If our teams aren't aware of what we're trying to accomplish and why, it's hard for us to hold them accountable. And I think two important ways to build awareness are, again, to discuss those performance factors up front, and then incorporate the performance-related requirements into the acceptance criteria or as constraints. We also need visibility. Awareness is one thing, but again, if we're not constantly reminded of how important performance is, it's likely going to slip into the background. I found the best way to keep performance visible is to ensure that our definition of done requires us to document those performance factors and performance-related acceptance criteria as part of our stories. But remember, some criteria you may not be able to prove until you've got a more production-like environment. I've also seen some organizations create a role of performance owner. I know of one group that even called it a performance czar. But But note that the responsibility of this role was not to own all things performance and be responsible for all things performance, but really rather to ensure that the teams were adopting a culture of performance accountability. They were more responsible for clearing the way for performance by providing guidance and ensuring that teams had what they needed from a performance perspective. So accountability is certainly one thing, but I think it's unfair to expect that teams will magically have the skills and tools to implement performance-related processes into the delivery cycle. You have to start building that expertise, and I would suggest one team at a time. If you're a part of an organization that has or had a performance testing center of excellence, you can bring that expertise, those experts, into your teams and start seeding them with the appropriate processes and skills. And once teams then start to become self-sustainable, you can start to expand that to other teams. And in parallel, I think it's a good idea to develop what I call a virtual COE, or Center of Excellence, that can provide guidance and oversight for performance-related activities. And I'm not talking about heavy processes or oversight, but a virtual community that can work together to share ideas, lessons learned, and ensure continued improvement and growth in the performance arena. You also need to think about bringing the appropriate tooling into upstream environments, not just load generation tools, which may be in place already, but also performance monitoring and diagnostics, perhaps, that will help you understand more than just user level metrics. But as you do this, it's a great way to move from where you had a separate centralized performance team to having performance analysis integrated with your delivery teams and making them self-sufficient with that respect. So now that we kind of understand what that is, what continuous performance is, and why we would want to achieve that, let's look at where we can learn about performance within our pipeline. And I think a good way to start thinking about that is to look at a pipeline. I've laid out a relatively straightforward one here to help with the conversation. So of course we can learn about performance in the performance or load environment or stage. That's where we're likely going to execute something that looks more like a traditional system level performance test. But as we'll discuss, we're not going to execute this, at least not likely, on every build. Can certainly learn about performance at the integration stage. And this is going to be focused, though, more on individual components or smaller groups of components, tests that we can execute quickly and get fast feedback on. Tests that are going to have few dependencies, or at least have their dependencies mocked. We'll also discuss how we can learn about performance in production, and not just from traditional monitoring perspective, but also using other techniques as well. And finally, we might even be able to learn something about performance when code is committed. It certainly depends on what we're doing, but we'll spend a little time talking about that next. The key, though, is to evolve to a state of regularly evaluating performance, so it becomes easier to track performance regressions to the commit where they were introduced, right? The old traditional way of performance testing much less frequently leaves many possible culprits that are going to require investigation and possibly not even the time to deal with them. So over the next few slides, we'll take a look at each of these pipeline stages in a bit more detail. So let's start at the beginning of the pipeline and see what we might be able to learn about performance at the commit stage. And what I'm really talking about is unit performance testing. And yeah, there's some organizations that are practicing this. There are even some tools and libraries that are purpose-built for unit performance testing. The table here is something I gleaned from a somewhat recent research paper out of Charles University in Prague, and it lists the most popular performance unit test frameworks. But we should definitely note that popular is a relative term here. This study reviewed almost 100,000 Java-based projects in GitHub and found that only about 3% had some form of performance unit testing. It's also important to note that of these of these projects, the vast majority, I think about 72%, use JMH, which is part of OpenJDK, to accomplish their performance unit testing. So let's look at what performance unit testing might look like. Certainly not every method is going to warrant performance testing, right? But there's going to be some benefit to testing performance at the unit level where it is appropriate. And these should be true unit tests where you've mocked out the dependencies. You're just running them with multiple threads or multiple iterations. We want to run them as part of the build process, but that can be problematic because you don't want other things going on in that environment to impact the results. But frameworks, especially like JMH, can help you package up your tests as part of the build process and move them over to a more pristine environment and execute them there where there's going to be less impact from other things that might be going on. Certainly some important considerations for including performance unit testing in your pipeline. And probably two of the most important are first controlling the length of the tests and how results are presented. Tests would have to be run too long to gather enough data to give you a high confidence level from a statistical perspective in small performance fluctuations. Therefore, we really need to understand that they're going to detect really, and we can only be confident in obvious changes in performance. And at this stage of the game, that should be fine for most applications. Second, absolute value of the results is less important, especially for things end user type metrics like response time, much less important than the trend of those numbers from build to build. Reporting individual results back to developers is certainly much less important than showing them how performance was impacted by their last commit. I also should mention that these unit test or unit performance testing frameworks have assertions, but I wouldn't have your performance tests break the build necessarily, especially at first when you're just first starting to implement this practice and gather the data. It's not, these tests aren't deterministic like functional tests where there's an obvious pass and a fail. So you need to understand the data a little bit better before you take the step of having a performance test break your build. So let's move down the pipeline. We can definitely learn about performance at the integration stage, and this is after we've checked in code, our unit tests have passed, and now our CI server is deploying a new build into our integration environment. So what does that look like? Well, it's a test focused on individual components, and these should be your most critical components, at least at first, especially if you're just getting started. We can always scale that once we've gained some experience and worked out the kinks in the process. We're still early in our pipeline and we want fast feedback. So these tests that include typically individual calls that are executed by a small number of concurrent threads for a small number of iterations. We're not trying to execute a real life user load or throughput load at this point. We want to limit the complexity of our test setup. So again, we'll want to mock out any dependencies that the components might have. We should also think about measuring not just response times, but perhaps also system level metrics by extending our performance monitoring tooling into our delivery cycle if it's not there already. Also some important things to consider here in this stage of the pipeline. We want to execute these results on every build that gets deployed here if possible, but similar to unit performance testing, the results are not necessarily deterministic. Probably shouldn't have tests break the build. And again, we're not looking for absolute results here, right? As we just discussed, we're not putting real life load on the system. It's not a production-like environment, most likely. So what we want to do is look for trends across builds. We're not trying to answer questions about how the system is going to perform in production at this stage. Rather, we're just trying to get feedback about the performance of a component. So if the delivery team sees something they don't like, they can just start addressing it as soon as possible. So the picture I've painted here, as I've talked about this, is a relatively mature implementation. I don't recommend that you go back and try to recreate this immediately in your environment. Not because it's necessarily difficult, but more because you want to build this in a way that is sustainable by your organization and provides value that's specific to your organizations. We'll talk about the implementation approach in a little bit more detail in a bit, but most organizations start with a single component test, maybe even triggered manually at first, just to kind of get a feel for how that works and the type of data that the organization can get from it. So before we move down the pipeline, I want to dive in a little bit here. And we just talked about performance at the unit and component level, but we shouldn't be naive, right? For many applications, that's much easier said than done. If we have a microservice-based architecture, it's certainly more intuitive at the component level to design tests. Each component is likely relatively focused in what it does and identifying its dependencies for the purposes of understanding mocking or service virtualization requirements is relatively straightforward. They lend themselves fairly nicely to short, focused tests that can be run efficiently in upstream environments. However, for monolithic architectures that I think most of us deal with still, the idea of a component can get a bit fuzzy. And therefore, the ability to execute nice, neat little tests that focus on a specific component become considerably more difficult. But I think while you may not be able to accomplish the same level of compartmentalization, there's some things that we can do. A good place to start is to map user actions to specific areas of interest in the application. This might be a specific process in the application or in the business logic layer, or maybe a specific stored procedure. But rather than thinking about testing from the user perspective, think about the areas of this monolith that might have performance issues, or based on your knowledge of the system, are good candidates for performance testing. Then identify user actions that exercise those areas. And the test should only include the minimum number of steps necessary to hit those interesting areas, right? We want to avoid those end-to-end flows, because now we get more brittle scripts that take longer to set up. And that just doesn't fit very well early on in our delivery cycle. So for those reasons, right, for monoliths anyway, the scope of performance testing that we can do early in the cycle may be limited. These are going to be tests, because it's of the monolithic architecture, the tests are likely to be a bit longer and have more dependencies. So our time to maintain them is going to be greater, and the ability to mock dependencies and set up data will likely be more limited as well, and require more setup time. So we need to be very critical about the tests that we create here, especially from the monolithic architectures. So let's move on to the acceptance stage. It's common to have an inline, and what I would call an inline environment anyway, where additional component tests can be run, or maybe small subsystems of components, but also have an out-of-line environment. Again, this is more a production-like environment where that more traditional system-level performance tests are performed. For the inline environment, this is typically where you'll be running your automated acceptance and regression tests, so your automated functional tests. So I recommend capturing end-user performance metrics as part of those automated regression tests if possible. And most frameworks can be modified fairly easily to capture this information, things like response times or user and browser level metrics by tapping into the browser API. We can even capture much more detailed information via HAR files by running our application through something like browser mob proxy. And this data can be saved off as part of your automated regression execution results, and if necessary, then sucked into a time series database for analysis if necessary. Again, ideally, we'll be executing component level tests on every deployment with the dependencies mocked. And then for that out-of-line system level performance test, which again, probably going to be executing less frequently. The key is that if you're evaluating performance throughout the delivery cycle, tests you run, the more traditional system level tests, you can be much more selective about when you run them. They're much more effort intensive and of course, probably much more expensive tests to run. For those system level performance tests, all the recommended practices still apply. There's not any magic just because we're in a DevOps environment. we still need to make sure that our user and load profile, so the number of users, what they're doing, their throughput level is appropriate, right? We're designing a good test. We need to understand the test data requirements, and we've set them up accordingly. We're prepared to monitor, again, not only those user level metrics that our test tools will give us, but system and infrastructure level metrics as well. I have seen, rarely anyway, organizations execute this level of testing more frequently even as part of an automated deployment. But it's difficult, right? Environment provisioning and configuration, data setup all need to be part of that automated process. And really the hardest thing about that is making sure the tests themselves are ready for execution and they haven't been impacted by application changes. So before I move on and talk about testing and production and a couple other topics, I want to give a conceptual overview of the process and some representative technologies that might be used to put this all together. I've listed some tools here, but they're just examples. They're not necessarily recommendations. So let's first start out with whatever we're testing, right? Our system under test. We need some tool to generate load and throughput. And because we want more than user level metrics, we're monitoring the application and infrastructure while the tests are executing. We'll want those results to be collected, right? So from both the load tools and the APM tools, and again, ideally in some type of time series database. And we'll want some mechanism to alert the people that the tests have completed, or perhaps any anomalies were detected. And of course, we want to make those results available to anyone that needs to see them. And of course, we want the entire process to be automated as possible. And you're probably looking at this and thinking, hey, this seems like a lot of work, and I don't see how I can carve off time with everything else in my backlog. And you're right, this is not a trivial amount of work. For organizations that kind of organically evolved to this, it was a many months, in some cases years, process or evolution to get here. But it's also important to note, you don't need to build this overnight, right? Or in one kind of complete project. A good place to start, again, is executing a few simple component tests automatically as part of your build deployment. Maybe getting an APM solution running in that environment if it isn't there already. Then evolving to results collection, and then finally broadcasting the results. I mentioned the backlog, and this work should be part of your technical backlog, so it becomes part of your efforts toward continuous improvement. I think in organizations, at least that I've worked with, where this work was done, quote unquote, off the books, it definitely was put on the back burner a lot because there was no visibility to it. It was something we'll get to if we have time, and as we all know, right, we rarely get into that state where we have time. So organizations that have been much more intentional about this and made these efforts part of their technical backlog did a much better job of prioritizing it along with the other work they had to do and actually making progress. So again, a lot of information, right, in the last, 35 minutes or so. But I think it does paint a good picture of what continuous performance can look like and the value that it adds. And before we move on with a couple topics on production testing, as well as monitoring, and before you start just implementing go back and implement this in your pipelines, we really should maybe take a step back and think about some of the realities associated with the implementation. So first, I recommend, and I mentioned this a couple times, start small, right? Start running some component level tests against a few of your more critical components. Get comfortable with that process and the tools that it takes to execute the test as part of your CI pipelines, and get the information to the team in a consumable and an actionable state. Work out the kinks in that, and maybe scale to other components and other stages of the delivery cycle. As I mentioned, this shouldn't be off the books work, right? Make the implementation part of your technical backlog. Part of getting comfortable with this process is not overwhelming your team, right? Another good reason, of course, to start small. This is information that the team likely hasn't received before, or at least not with any regularity. So you need to prepare them so that they're not only ready to consume it, but they understand it. And just as importantly, they have to be prepared to act on it. Much of the value of performance testing is in the analysis. But we can't assume that our teams possess the ability to understand the data that we're giving them and much less take action on it, right? This is going to be a learning process. And successful performance testing activities, they aren't just implementing tools, right? There are some supporting factors that we need to make sure that we take care of. We don't have unlimited time to execute tests, so we need to think very critically about which tests are important. And if these tests are going to be executed as part of a delivery pipeline, they likely need to be run on demand. So we need to understand what that means from a test environment and a data perspective. Finally, this is not going to be a fire and forget solution. As you implement continuous performance testing, you should continuously get feedback from the team and improve the solution so it's adding the appropriate value to the delivery cycle from everyone's perspective. As the ability to understand the performance data and take action on it evolves, the delivery team can provide valuable feedback on what information they get and how they get it. And of course, this shouldn't be done in a vacuum. Everything that we're doing should be happening out in plain sight. To ensure that you should make that again part of your technical backlog and continuous improvement efforts. Okay, before we wrap up, a couple of miscellaneous topics. First, let's talk about what we can do about performance evaluation in production. And I think most of us are probably monitoring our applications in production, at least we should be. But testing in production, while certainly once was taboo, is fairly common today and an important part of a continuous performance strategy. From a testing perspective, I think the obvious benefit is the confirmation that production can support expected load conditions. But often we don't get the ability to put a full load on our production environment unless it's a brand new system and we don't have users on it yet. In addition, it allows us to test the entire system, not just what's behind the firewall. And with the wide availability of cloud-based load tools, we can evaluate the user experience from various locations and network conditions. And when we can combine testing with monitoring to give us specific data that we want by executing synthetic transactions in production. And we should create a continuous feedback loop between upstream testing and monitoring in production so we can improve both test design as well as the monitoring configuration. And of course, with everything else, there's some key considerations that we need to think about, right? Testing in production isn't as easy as pointing our test to the prod environment. There's some things we're going to have to do to maximize the benefit and, of course, minimize the risk. One mistake I see, especially from the performance testing side, is creating this strategy in a vacuum, right? We need to get input from across the organization so we can put together a comprehensive plan that's giving us data that adds value. If our app is hosted in a third-party environment, we need to coordinate our testing efforts, especially if it's large volumes. So we don't risk making them really unhappy, at least, or more likely the case today is being blocked because they think it's some type of denial of service attack. Of course, if your app is already live, you have customers. So you either need to find execution windows that minimize that impact or possibly cordon off part of the environment to handle the customer traffic while the test is being run on the remaining portion of the environment. Ideally, the system should know it's being tested. Right? After all, we're in production and we can really screw up the business depending on what we're trying to accomplish. Whether it's using custom headers that the application recognizes as synthetic, whether it's seeding test data in production that only that no one can see other than the tests themselves, or some other means, you need the system to understand that it's dealing with these synthetic transactions. Again, this is another reason to have broad IT input. You'll find that if the system is architected from the beginning, or at least adapted over time to be tested in production, this all becomes a lot easier. Finally, it's a good idea to eliminate or mock requests to third-party services. So as part of your testing, you don't unintentionally impact their customers as part of your testing effort. So last topic I wanted to touch on, as we talked about testing and monitoring, it's probably worth taking a quick look at the differences between them, as well as how observability, which is a relatively new area, and how they complement each other. I've seen a lot of opinions that argue that maybe sufficient testing reduces, or in some cases even eliminates, the need for monitoring. On the flip side, I've seen some arguments that say sufficient monitoring eliminates the need for testing. I think both are pretty ridiculous. Rather, testing, monitoring, and now observability complement each other by giving answers to 3 distinct types of questions. If we look at testing, that confirms the answers to questions that we already know the answer to. Where monitoring gives us the ability to answer questions that we don't yet know the answer to, right? The example there is will page-to-page response time in production always be less than a certain value? Well, we don't know that unless we monitor it. And finally, observability really goes a step further and gives us the ability to answer questions that we didn't know we would even have to ask. I think with respect to the term observability, there seems to be a bit of confusion. In fact, you'll see many monitoring solutions claim that they offer observability, and certainly in a way they do, right? They show us data from many different perspectives about how our system is operating and performing. But typically that data is aggregated with no ability to back into the raw kind of superset of data if we need to. So at least in my opinion, true observability is the ability to efficiently get at every single data point and ask questions that have very high cardinality, such as here the example that I'm showing, right? We've got specific users that are on a specific version of something that are doing a very specific action at a very specific time, right? A true monitoring solution that aggregates the data would be very, very difficult to get down to that specific level. So before we take some questions, I want to talk about some things that I want you to take away, independent of anything else that we talked about in this application. First thing is that traditional end of cycle performance tests just don't fit very well with agile DevOps delivery cycles, right? They typically take a long time to plan and set up. They come along with some very rigid rules, and that just doesn't fit into a 2-week implementation sprint. When we think about continuous performance testing or continuous performance evaluation, right, it's not just doing more or faster performance tests, especially traditional performance tests. While I think that's an intuitive way to first approach it, it's because of the shorter delivery cycles. There's a lot of data out there that shows that it just doesn't fit very well. But along those lines, we can learn about performance at every stage of the delivery pipeline. We just need to be very intentional and specific about what we're trying to do in each of those stages. Finally, again, start small, right? This isn't going to be something that you lay out a big project plan for and start working on and then come out with the right answer at the end. Start small, iterate towards your solution, get feedback from across the organization. A big part of the DevOps culture is that culture of continuous improvement, and that needs to be applied here as well. And again, if this becomes part of the way you work, it's out in the open as part of your technical backlog, I think you'll have a much higher degree of success in making that happen. All right, so if there are any questions, Magdi, please let me know. I'll do what I can to answer them.
All right.
Of course.
Lee, first I want to thank you so much for giving the time and to share your experience and knowledge. This is certainly a very important webinar here. I got a couple of questions here. The first one says, who has to own the CPT process?
So that's a very good question. So I think the first part of the answer is someone has to, right? I've seen organizations where it was more of a mandate of, okay, delivery teams, you're now going to be practicing continuous performance with maybe only a little guidance on what that means. Someone has to own it. They need to define what that means. So what are we going to look at each level or each stage of the delivery cycle? What roadblocks are in our way, and what needs to be removed so we can make that happen. So it's typically a role. If the organization had a performance testing center of excellence, it's someone from a leadership position that came from there, someone who understands what performance testing is, what the processes look like, what available tools are there, and at least initially provides that high level of oversight and governance as the teams start to become self-sufficient. Over time, that owner, again, it's less important who it is. It's more important that there is one. That owner, the singular ownership of that tends to be spread over that virtual center of excellence that I mentioned. It becomes the virtual seat. The ownership now is owned by that virtual center of excellence that together provides a COE. But that can only happen after you've started to scale it beyond the first delivery team.
Okay, got another question here. How do we engage dev owners to be part of the CPT cycle?
How do we engage the dev owners? Is that what was the question? Yes. So yes, and again, right, it's very important for them to be engaged. Probably the first and most important level of engagement is helping them understand what information is important. Typically, I see that as again, that performance test owner providing some education on what's available, what performance data looks like, but then also that opens up the dev owners' minds to what's possible, right? And they typically come up with additional ideas and start to expand the type of data that they can see. The next is making the actual practice part of the way they develop software. So how do I create a component level test? It's something that they already know how to do, but how do I do that within the kind of within the structure of a performance test tool? So now I can do it with multiple iterations, multiple threads. Where does the data go? How do I get that in a way that I can consume it and take action on it? So it's engaging them to understand what they can do, and then start to get them ramped up on the specific practices. But it ends up being a continuous feedback loop, and eventually the teams take ownership of it, and that's when you start to see that. Then you can start to scale it to other teams. Very good question.
All right. Another question here. We currently have a separate performance testing team that operates as a shared service. What involvement should we have supporting continuous performance testing in our delivery teams?
Yeah, so again, having that separate performance team, especially in a larger enterprise that might operate as a shared service, is relatively common. And as I said, right, it made sense as part of the waterfall cycles. But they have a lot of performance-related knowledge. So as that first question alluded to, right, who's going to own it? Well, probably someone from that performance testing team is going to initially own it. Right, they can begin to enable the delivery teams to understand what performance-related activities they can start to implement in those delivery cycles. Right, and a good way to do that is loan members of that team out to the delivery teams, right? And they may, again, they'll serve as the performance czar, the performance owner, get these processes in place for a single team, and then as they become self-sufficient, start to scale it. And another benefit is they can bring the process and tooling expertise to the teams and start knocking down those obstacles that we talked about earlier. But it's important that the processes that are likely in place, right, with that shared services team, they're likely focused on end of cycle Big Bang performance tests, right? So those team members need to pull themselves back a little bit from that and not just do what they did in the past with these new delivery teams. They need to think more generally in ways that we just talked about with respect to performance activities at the different stages.
One more question. We have previously tried component level performance testing against our service layer, but the data we generated was largely ignored by the organization. Can you offer any tips to improve the acceptance of this activity?
Yes, and again, this is unfortunately is not an uncommon scenario. Right, we have to remember that the delivery teams that we're generating this data for probably haven't seen this type of information, certainly not with any regularity. And I talked about the importance of involving the team in this process. They really need to understand the information they're given, but more importantly, they need to be ready to act on it. So if you're giving them this performance-related info, but their culture or way of working has them focused on deadlines or addressing pure functional issues, they might appreciate the data that you're giving them, but they're really not in a place that they can act on it. So you need to involve the team, talk to them about the types of information that can be provided and why they're valuable. The team's going to have some input, possibly some pushback, but this is going to go a long way to helping them internalize it. And you definitely don't want them drinking from a fire hose, right? If we just start with a few of the more critical components and then get some feedback on how they're receiving that information and what they're receiving, you can iteratively expand and improve at the same time. And the key is to involve the team as they eventually need to become the part of, or continuous performance eventually needs to become part of the way they deliver software. They're probably used to having performance testing done by someone else. If they're all of a sudden being force-fed this information, it's going to be quite a shock, and the reaction is going to be to ignore it. So the more you involve them in the process and more that they can mold the process, the more likely they're going to see the value in the data provided. But again, start small, go slow, get the process down, and then you can speed up and expand.
Well, I think that concludes our questions. Lee, I want to thank you so much again for sharing your time and experience in this webinar. For everyone else, thank you so much for joining us in this webinar. And please go and check the Testing Institute website, www.testinginstitute.com or iist.org, a short version of the URL. This webinar, as I said, is being recorded now and will be available at the iist.org website next week. Again, thank you so much for joining us in this webinar. Thank you, Lee. Thank you much.
Thank you.